Alright guys, so on page 13 we're going to review factoring quadratics in the form of ax squared plus bx plus c. This is just going to be a review from your Algebra 1 days, and so we'll practice more tomorrow in class when we come back together. So I've put all of the different methods here, and so this is what the front of your foldable needs to look like once you have it created. And so if you need to pause at this point, go ahead and do so that you can put these titles for your tabs. So the title of this is Steps for Factoring Quadratic Functions. We have some techniques here. We've got the greatest common factor, or GCF for short. We have what's called a difference of squares, which is in the form of a squared minus b squared. We have perfect square trinomials, which are in the form of a squared plus 2ab plus b squared. And we have your trinomials ax squared plus bx plus c. And we also have a shortcut if you want to try to follow this, and some of you may already do this. It's factoring by unfoiling. So when you open up the first tab for greatest common factor, or GCF, I've got some steps here for you. So go ahead and start writing those down. Pause the video at this point so that you can do so. The steps are to find the GCF, the coefficients and the variables, and write it down first. Once you have that, step 2 is to divide each term by that GCF and write this in parentheses after the GCF. And then step 3 is to check your answer by distributing your GCF back in, just to make sure you have the correct answer. So your first example, it's the directions say to factor each quadratic expression. So example 1 says 3x squared minus 15x plus 9. This is a quadratic. And so if you look at the variables first, x squared, x, there is nothing with the 9, so there's no variable in common that they have. However, if you look at the numbers 3, 15, and 9, they all do share 3. So that's going to be my GCF, and I'll pull that out in front. In parentheses, what's left if I divide each term by 3, I'm going to get x squared minus 5x plus 3. And so the GCF of 3 is on the outside, and in the inside is what's left after dividing that GCF out. Now you could check your answer doing step 3 by distributing that 3 back in. So that would be 3 times x squared, which is 3x squared, 3 times minus 5x, which is minus 15x, and 3 times positive 3, which is positive 9. So you know you have the right answer. Example 2 is 5x squared plus 15x. Looking at the variables this time, they do share an x in common, so that's going to be part of my GCF, and also a 5 between the 5 and 15. So I'm going to pull that 5x out, that's my GCF. Then in parentheses, when I divide each of those two terms by that GCF, I'm left with x plus 3. Now, you can distribute that back in. 5x times x is 5x squared, and 5x times positive 3 is plus 15x, so you know you have the right answer. And that's it for this tab. Tab 2. Again, go ahead and pause your video so you can write down the steps. For this one, we have a difference of squares. This is the form of a squared minus b squared. You'll notice that it's a binomial. You'll notice that there's a subtraction symbol in the middle. That's why it says difference. And you'll notice that the first and the second term are both going to be perfect squares. They don't actually have to be perfect squares, but they're going to be squares. And that's the reason it's called a difference of squares. So step 1 is to take the square root of the first term. You're going to call this a. Step 2 is to take the square root of the last term. You're going to call this b. And then finally, your answer to factor this is to write your answer as a plus b, a minus b. So we've got 4 examples. Example 1, your directions say to factor. Example 1 is p squared minus 4. So the first term is p squared. If I take the square root of the first term, that's going to be p. I'm going to call that a. So far I have a equals p. Your second term is 4. Notice I'm not saying negative 4 because it's the minus and then b after the minus symbol. So my b is 4 in this case. And so therefore, minus b squared. So 4 is going to be my b squared. So when I take the square root of 4, that's going to give me 2. And so now I have b equal to 2. Well, your answer is written as a plus b in parentheses times a minus b in parentheses. So when you write that for this particular problem, your answer is p plus 2 times p minus 2. And that's how you would factor p squared minus 4. You should still check your answer by foiling this back out using FOIL. If you do that, p times p is p squared. Your inner is positive 2p. your outer is negative 2p, and your last is negative 4. You'll notice a positive 2p and a negative 2p will cancel out, leaving you with p squared minus 4, so you know you have the right answer. For example 2, we have 9m squared minus 64. In this case, my a squared is going to be 9m squared. Therefore, when I take the square root of that, it's going to be equal to 3m, and I'm going to call this a. For my second term, it's 64. This is my b squared. So when I take the square root of that, I'm going to get 8, and so I'm going to label this as my b. So my final answer is going to be quantity 3m plus 8 times quantity 3m minus 8. Again, you could check your answer, but I'm not going to this time. Example 3, we have 3c squared minus 27. You'll notice that 3c squared and 27, actually neither one of those are perfect squares, but really I should take out a GCF first, because the greatest common factor is always going to be the first thing you want to do ever before you factor anything. So in this case, there's a GCF of 3. So I'm going to put 3 parentheses c squared minus 9. And now c squared minus 9 is a difference of squares. C squared is going to be my a squared, and 9 will be my b squared. So when I call and I set this up, my a is going to be c, and my b is going to be 3. So when I did this wrong on my paper. Please fix this for your paper because mine is wrong. I'm so sorry. This should say 3 parentheses c minus 3 parentheses c plus 3. So that's my mistake. I apologize. Fix that for me. And then finally the last one for number 4. We've got 50p squared minus 32. Same thing is true again. 50p squared and 32 are not perfect squares. So what I'm going to do is I'm going to factor out a GCF because they do both have 2 in common. When I do that, I've got 2 parentheses 25p squared minus 16 in parentheses. Now, 25p squared is a perfect square, and so is 16. There's a subtraction in between, so this is a difference of squares. My a is going to be 5p. My b is going to be 4. So when I write out my whole answer, it's going to be 2 parentheses 5p plus 4, 5p minus 4. For the next tab, we've got a perfect squared trinomial. Perfect squared trinomials are in the form of a squared plus 2ab plus b squared. It is going to be a trinomial, and the first and the last terms will be perfect squares. So for the steps, go ahead and pause your video now. Step 1 is to take the square root of the first term. You're going to call it a. Step 2 is going to take the square root of the last term, and you're going to call it b. Notice these are the same 2 steps that you use for difference of squares as well. You do have a step 3 because there is a middle term since this is trinomial. And the thing you have to do with this is you have to check if the middle term is twice the first and the last term being multiplied, so twice the product of a and b. Step 4, if this is true, you're going to write your answer as either a plus b quantity squared or a minus b quantity squared. And I'll tell you in a little while with an example to see the difference, so you can see the difference between which one you choose. And then step 5, if you do not have twice the middle term, if your middle term is not twice the product of a and b, then you can factor it using the steps of ax squared plus bx plus c, which will be the next video, or the next tab in just a moment. Now technically you don't have to perform all 4 of these steps for perfect square trinomials. It says right here that you could go straight to step 5 and use the techniques for factoring ax squared plus bx plus c that I'm getting ready to show you. Alright, so for our first example, it says your directions say to factor the examples completely. So for step 1, we have x squared minus 10x plus 25. So I'm going to first check to see if this is even a perfect square trinomial at all. So the square root of the first term is x, I'm going to call this a. The square root of the last term is 5, so I'm going to call that b. If I multiply a times b together, I get 5 times x. If I double it, I get 10x. Now looking at the middle term, that is the middle term, so now I'm going to go ahead and factor it using the shortcut that I was given. Because there's a minus 10x in the middle, I'm going to choose a minus b squared, giving me the answer of x minus 5 quantity squared. Now, if you're not sure if this is the right answer, you could always FOIL it all out by multiplying x minus 5 times x minus 5. And when you do that, you will get the result x squared minus 10x plus 25. For example 2, we have 4x squared plus 12x plus 9. I'll take the square root of the first term, which is 2x. I'm going to call this a. The square root of the last term is going to be 3. I'm I'm going to call this b. I'm going to now double check to make sure that if I multiply a times b and double it, that I do get the middle term. And so in this case, I do truly get 12x because 3 times 2 is 6, and then 6 times 2 is 12, so I get 12x. Now this time I end up with a positive 12x for my middle term, so I'm going to choose the positive symbol this time. And I'm going to write my answer as 2x plus 3, all quantities squared. And so now if you were to FOIL that out, you would multiply 2x plus 3 times 2x plus 3, and you would get back the 4x squared plus 12x plus 9. All right, for the next tab, these are your steps. Pause the video. So step 1, you're going to be in the form of ax squared plus bx plus c. This is a standard form of a quadratic. And so a is going to be the coefficient of the x squared, and c is going to be your constant. So step 1 is to multiply a times c, and you want to list the factors of whatever that product is. Step 2 is to find two factors of a and c that sum to be b, which is your middle term. Step 3 is you're going to rewrite that middle term bx using those factors from step number 2 that you created, or that you found. Step 4, you're going to factor by grouping. Now, factor by grouping, you're going to have 4 terms, and you'll see this in an example in just a moment. You'll have 4 terms altogether. So you're going to factor out the GCF from the first 2 terms when you factor by grouping. Then you'll factor out the GCF from the last 2 terms. And then you'll have 2 additional terms, and these 2 terms should have a GCF, and then you're going to factor those 2 out from the result of 1 and 2. If none of these steps can be done, the quadratic is called prime. I'll show you an example of that in just a moment. So here's example 1. We've got x squared minus 5x plus 6. We know since there's nothing in front of the x squared that the coefficient there is going to be 1, so a is equal to 1. Your constant in this case is 6, so c is equal to 6. So I'm going to do a times c, and that's going to be 6 in this case. All of the factors of 6 are 1 and 6, negative 1 and negative 6, 2 and 3, and negative 2 and negative 3. In the right-hand column of that table, I'm going to sum all these up. The only one that gives me the negative 5 for my middle term that I need, that b term, is going to be the negative 2 and negative 3. So I'm going to split up that b term, negative 5x, using negative 2x and negative 3x. Those are the two factors that I got, negative 2 and negative 3. So if you do negative 2x minus 3x, that truly is negative 5x. So this is still the same thing as this original problem. I've just split up that middle term. Notice I now have 4 terms altogether. So I look at x squared minus 2x, and I take out the GCF of that. In this case, that is x. In parentheses, what's left when I pull that out is x minus 2. The second 2 terms are negative 3x and positive 6. The GCF between those are going to be minus 3. So in parentheses, what's going to be left is, again, x minus 2. This is considered one term. Even though there's several pieces to it, it's only one term. This is considered your second term. And so now these 2 terms, you'll notice, have a parenthesis that is the exact same thing inside x minus 2. So that's another new GCF. When I pull that out in front as my GCF, x minus 2 goes inside a parenthesis. And then what's left when I take that away from the 2 terms is going to be x minus 3. Now, if you FOIL all this out, you notice you will get x squared minus 5x plus 6. And so you know you've got the right answer.